Hello, in this video we would be learning about geometrical interpretation of angular momentum. Consider a particle of mass m moving from A to B on the xy plane, moving from A to B on the xy plane. This is the diagram. This is the diagram we are going to consider. Okay, x, y, z axis. Say a particle goes from A to B within a short time interval delta t. Right? And the position vector of A is r. I said already, particle goes from A to B within a short time interval delta t. That means this AB, which we have represented as delta r, is very small. Delta r is very small. And now what you do, you construct a parallelogram having OA and OC as adjacent sides. Join the diagonal OB. OB is the diagonal. OA, OC are the adjacent sides of a parallelogram. In that, R is a position vector of the point A, and the particle moves from A to B within a short time interval delta t, and AB is very small. Delta R is the vector form of AB, and delta R being the distance, it will be velocity into time. Okay, velocity at A is v. Got that? Okay. This is very clear because if AB is delta R and OA is R, then OB should be R plus delta R. OB should be R plus delta R according to law of triangle of vector addition. OA plus AB will be equal to OB. You got this as R plus delta R. Okay. Remember the physical situation. Particle is moving from A to B and time taken is delta t, which is very small. Okay. Area traced by the radius vector R in time delta t. Okay, this area traced by the radius vector r is a radius vector r. Okay, this radius vector is going like this. So area traced by the radius vector r in this time delta t, area vector, is given by half into r cross delta r. For that, we would use the idea which we get in vectors like this. So this is the parallelogram. OA is vector A, OB vector B. This is just to make you understand this, I have drawn here separately. OA is vector A, OB is vector B. Then complete the parallelogram OACB. Then area of the parallelogram is A cross B. Area of the parallelogram is equal to A cross B modulus, because area is going to be positive here. So it is to be taken as modulus of A cross B. So in this geometrical representation, in this geometrical explanation, we will consider mod of A cross B as the area of the parallelogram. Half of this will be area of the triangle OCA or area of the triangle OCB. Okay. So area of this triangle, that is half of modulus A cross B. Now come to this picture. Therefore here area of the triangle OAB is equal to half into mod of r cross delta r. Okay, triangle of modulus r cross delta r cross v delta t, because delta r equal to v delta t, delta r being a distance, v delta t is also distance. Okay, right. Next one is this delta t, that can be taken out and it may be brought to the left side. So delta A by delta t is equal to half r cross v with modulus symbol. Okay, so multiplying and dividing by m, and this m, now you can consider along with this 2. So 1 by 2m, this m you can bring it here. M is a constant, so just bring it before v vector. Okay, so when you bring this m here, you will get mv, which is nothing but momentum vector. Okay, fine. 2m. And this momentum vector here, that has been written here. But r cross p, we know angular momentum of the particle. So we are using this formula, L is equal to r cross p, and we got L here. Now I am just giving the magnitude here. So delta A by delta t, 1 by 2m, magnitude I have put here of L vector. L is what? Angular momentum, right? Okay. Now delta A by delta t is equal to L by 2m. What is L? Magnitude of the angular momentum. What is m? Mass of the particle. This delta A by delta t is called as areal velocity, because this represents area traced per unit time. So you can consider it as areal velocity. So if you write it in words, angular momentum indicates the product of twice the mass and areal velocity. You can also give this expression in vector form. Okay, L is equal to 2m delta A by delta t. Direction of the areal velocity will be same as the direction of the angular momentum. Understood this? Thank you.